My name's Steve Cobb. I'm product engineer for Lincolnton Furniture Company, and we manufacture solid wood bedroom and dining room furniture. And we use SolidWorks to engineer our case pieces, and we use AlphaCam to program our CNC routers. So pretty much what we do at the beginning is we have a designer send us a detail. And in that detail, of course, we have the sizes of the case piece and the detail of certain shapes. So what we do here in engineering is we take this design and break it down in a model. And in this model we are actually building the piece, so we make sure all of our components will go together after they're machined. So in this assembly, it's broken down per assembly. This is the carcass. That's the rear case assembly. That's pretty much how they are going to clamp it up. And within that model, it's actually broken down part for part. Let me show you a little bit of a shading there. So within this model, we do exploded views and things like that for documentation. So we can have some pictures or drawings of what the case is going to look like as it's built. Okay. So what we do here is we bring our solid model from SolidWorks into AlphaCam, and we pretty much just import it straight into the software with Solid. We might have to orient it into a certain position that works with our machine, but then from there we apply tool paths to the geometry that's extracted from the solid. And you can go ahead and turn all that on. And once all the tool paths are applied, we verify our machining with solid simulation. And this is from all the tooling that we have created in AlphaCam. It's pretty much a virtual of what our machine actually has out there in reality. And what we simulate out here is pretty much what the machine will cut. If we see anything that doesn't look right, we can correct it here rather than send it out to the machine and find out that it's not going to work there. And that's the finished part. After you can simulate a material in there and then simulate the tool path. Bring it up in Zilog one time, you don't have to save it or nothing. So what we're doing here is the program that's created in AlphaCam. We're bringing it up in Zilog. Go ahead and hit your EPL, Jimmy. This right here, it's pretty much showing how we're going to position the clamps. That's the locking phase, and pretty much what it does is he puts it up against the stops, hits the foot switch, and it clamps the part, and then it does all the machining. Right now we're cutting bedpost on the machine, so what we're doing is a pair of posts, and our cycle time is about 5.5 minutes. So he's going to call it up, hit the green button. We'll get right here. So that's the shuttle, the little shuttle right there. It comes up, and it's about a 4-second tool change, but it has to get all the tools in line first.
That's the 5-axis route track. about the benefits of CNC technology.
So what we're doing now is cutting apart, and we're doing all the trimming operations that we'd have to set up several machines to do. And so as we're going and using the B-axis of the machine, we're able to cut a rabbin apart, do any of the routes for our tenons on the bed. So even with 3-axis CNCs, you have the benefits of writing a program for one time, and then that's it. Every time you go to manufacture that part, you can call up the program, and maybe a 5-minute cycle time, and there you have that part. The benefits of a 5-axis is that you're able to do a lot more of the horizontal work than you couldn't do with the 3-axis. Okay. So right here, we just did that wrap. And we did the mortars for the rails, and we're going to have a panel in with that bed too. That's for the mattress rail, that's for the top rail, and these holes are for the inserts to lock the bed.
And it's all made from a solid model.
It's all made from the solid model that was created in SolidWorks, imported into AlphaCam, and then loaded onto our 5-axis CNC so we can machine it.